So during a solar eclipse, the sun, moon, and earth are lined up so that the sun shines on the moon, which then casts a shadow on the earth. And so in the United States, in the contiguous United States, everyone will have an opportunity to see at least a partial solar eclipse. And so that's when the moon moves across and partially blocks out the sun's disk. There is also a narrow path that moves from Texas up to New England where you can experience totality. So, for a brief period of time, as that shadow is moving across, you will see the moon completely block the sun out. And that then reveals the sun's outer atmosphere called the corona. The rest of the time, it's still a partial eclipse. But in that narrow time period, that's when you can experience the full aspect of what is a total solar eclipse. Well, yeah, so there's a couple of ways we can do that. So, except for that narrow time when you're in totality, the rest of the time is what we call a partial eclipse, where the sun is only partially blocked. And it's always too bright to look at just normally like the sun. So, what you want to do is if you want to look at it directly, you want to have safe solar viewing glasses or eclipse glasses. And then you're able to look up and safely see it. Now, if you don't have solar viewing glasses, then what you can do is you can create a projector which projects the sun's image onto a piece of paper or the ground, or you can even take a piece of paper with holes punched in it, which makes a pinhole camera that allows you to see the sun, the crescents cast onto the ground. You can even take your hands, do them like this with the sun behind you, and that creates little pinholes. And it's actually much like what happens with the leaves on the trees, which is just an amazing thing to see. Well, I am really stoked to see the corona. I mean, the corona, the outer part of the sun's atmosphere, is what I've been studying for 20 years, but I have always studied it from space when you can't actually see this part of the atmosphere. And the only time you can see it is when you're in totality on the ground. So I will see the part of the sun I study with my own eyes. But more than that, it's a really amazing experience. Once I first saw a total solar eclipse, I was hooked. And I'm really excited because I will get to experience this with my wife. And this is just such an amazing opportunity to share and with all of the people around you. Well, this is a really amazing opportunity. Nature is giving us a laboratory to study many aspects. One, of course, is the corona, which is very important. It's much hotter by 100 times than the surface of the sun. And it is where solar activity and space weather comes from, huge explosions that send out solar material. And so this is a really important opportunity to study that. But also, as we study that shadow moving across the country and we see the change in light in the atmosphere, it allows us to study the lower atmosphere, clouds and temperature, and it also allows us to study the very important upper atmosphere called the ionosphere, which is critical for our daily communications. And this is giving scientists a really special opportunity to do an experiment that can only be done during a total solar eclipse. Well, the sun has an activity cycle. It gets magnetically excited. The magnetism builds up in it, and it releases energy as it gets more and more twisted. So we go from very low activity or solar min to high activity solar maximum back down to low. We are currently either in or getting close to solar maximum. So this is the most activity, most space weather we can possibly see will be happening. And this is a great time to study that because it has such a huge impact on our society. And scientists will take this opportunity to learn more about our own star and how it affects our daily lives. It's an amazing achievement for humanity. This is the fastest totally autonomous spacecraft that's ever been created. And it's already, since 2018, been traveling, orbiting the sun, getting closer and closer. It's already started flying through the sun's corona, this part that we see during a total solar eclipse. And on December 24th, it will make its closest approach. It will be less than 4 million miles from the surface of the sun. Now, this doesn't seem like that's very close, but remember, the sun is 93 million miles away. So this is less than 4% a distance, allowing us to study this really important part of the sun's atmosphere. Well, yeah, so there's been a huge explosion in our ability to make better predictions, which also includes making better maps. And one of the keys to this is the data that we get from the Lunar Reconnaissance Orbiter. This has provided an incredibly detailed profile of the edge of the moon, which has a huge impact on how the shadow is cast on Earth and the structure of that shadow and the timing. We've also used data about the Earth itself. So combining the changes in the Earth as well as the structure of the moon has given us unprecedented abilities to predict the timing as well as the maps that we use to know where and when the eclipse will be. Yeah, so a transit is when a planet, for example, moves in front of a star. Now, of course, for the eclipses that we're talking about, the moon is moving in front of the sun and completely blocking it out. But distant stars have little planets that are moving in front of them. And by looking at how the light changes as the planet moves across it very subtly, we can see the size of the planet. The bigger the drop, the bigger the planet. But we can also look at the different colors of light that are coming through the edge of that planet, which is allowing us to study the atmospheres of those planets. This is something that's happening with James Webb Space Telescope, and we will be building even better instruments in the future to help us figure out if life is possible or maybe even if life exists on other planets outside of our own solar system. Well, there are a lot of great participatory science opportunities. Now, NASA has created several apps that you can download for your phone. One is called Globe Observer, which is a year-long project, but they have a special eclipse app that during the eclipse, you can participate and take measurements of temperature and clouds. There's also one called Sun Sketcher, which is allowing you to sketch and to take images of the corona, and Eclipse Soundscapes is allowing people to take sounds, to record sounds that are happening as the wildlife changes during the eclipse and bring back that data to allow NASA scientists, but also to have the public participate as a scientist to help us gather more data so that we can better understand all of the amazing things that we can learn during a solar eclipse. Well, it wasn't too long after Einstein had proposed his theory of general relativity, which basically says that a massive object like the sun literally bends space. And a consequence of that is as light travels through that bent space, the light itself bends. And so the gravity of the sun acts like a lens and bends starlight when it travels around it. So during a total solar eclipse, when the bright disk is blocked out, we can see background stars, but the positions of those stars are slightly shifted because of the bending of the light going around the sun. So we know exactly where they are. We see them in a different location, and that allows us to confirm the results of what general relativity predicts will happen when that star's light passes the sun. Well, the viewers can go to go.nasa.gov/eclipse 2024, and there you can find out about the citizen science you can participate in, see live feeds across the country, and find out about all of the opportunities so that you can participate whether you're in the path or out of the path. There are lots of things that people can enjoy and take that experience and have it be something unique, something that they can experience and share with all of the people around them.